Hello everyone, April 11th. All right, let's take a look. Deepest leaves sum. Oh, it's a tree. I love trees. Given the root of a binary tree, return the sum of values of its deepest leaves. Okay, so we just need to find the deepest leaves. Okay, this is 15. What is this? Now value, number of nodes in the tree. Okay. What is this tree? So adding them together, 19. That's 10, 19. Oh, okay. Hold on. Deepest leaves, which means if I do another one, the answer should be 11. Right? Because 11 is the deepest. Yep. Which means we do BFS. So BFS. We take the sum of the last one. Yeah. BFS. Alright, do you still remember the good way to do BFS? I might, as we start. The two, yeah, I think it's what the two array solution to do it. We don't need to have a deck. Okay, it's gonna be like this, and it's a tree, so we don't use our own test case as usual. Okay, so it's gonna be BFS. We have a queue. I remember it's a queue gonna be like this, right? And then I'm gonna have queue for root in it, and we say while queue, right? And then we're gonna have a temp. I'm trying just to remember how this thing works, and then we say for node in queue, right? A node in queue. Do res is 0. Then we have t-list, t-res, temp list to temp res, right? So for node in queue, t-res plus equal to node.val, right? And then if node.left, say t-list.append node.left, if node, and do the same thing, node.right, and push right in. Right after that, after we're done, res equals t-res, q equals t-list. Do we have to? No, we don't have to. We just did this. And then when it ends, we return res. Maybe. And this is getting, I'm getting the sum of each level, and then the leaf is just the last level. Let's take a look. Do that this. 1, 2, 3, 4, 5. 19. This should be what, 14? Yeah, I think I probably got it. One more test, 2 more tests. I want to test this. Is a complicated case. 15, and we also do something like this. Right. Because it says the number is 1, so empty case we don't have to consider. And this definitely should be right. Alright, try it. Pending. Yep. So it's basically it's a BFS BFS compute the sum of the nodes in each level. Return, yeah, I should just say BFS and then return the sum of the last level. All right, and let's make it a little bit cheeky. So we'll do like this. And then this is also like this. And Q equals T list. Yeah. Update Q and the rest. Update. Yeah, I just call it update. Yep, that's it. Details. The runtime is ON because it's ON because BFS 88 milliseconds and 86% ranking. This is probably an easy question. So I see that we don't have a solution, so we're just going to search for it. Should be easy. Oh, medium, but it has it's an easy one. It's like just a BFS. There's nothing special into it. Level traversal, recursion, BFS. Take a closer look. Q. Well, pre. Pre are nodes in the previous level. Q are nodes in the current level. On current level, empty the previous level deepest leaves. There's a new way to do BFS. Q, pre-Q equals Q, Q equals in this if child. Nice. Very good. This is another way. I mean, it's the same way. I have pre. Yeah, it's about the same way. Oh, pre and Q. Okay. Q equals this. Pre equals Q. We never touch pre. We just keep traversing. Okay. Okay then. Initialize 10. Where did he initialize 10? Yeah, the two gods. All right. Always update. Always upvote. I don't think I'll write this. I mean, this is how I will approach BFS. It's clean and easy to do, but what should I say? This is also quite good. Well, this is like the queue, right? So basically, what it says, it's not accumulating as we go. It's just traverse the levels. And each level, we put the next level into, yeah, so I use the Python internals to store the temporary level. This is the temporary level, right? This is the temporary level. And then I store this in here, and then we need to record it, right? When we record it here. Now we actually put this one, so Q equals this one, and we put the pre. Now, that's pretty nice. All right, let's write it. It's tempting. It's very tempting. It's interesting. Like a new type of BFS. Always, like, if you find something interesting, always write it out because it helps you memorize. All right, so we have a Q. This, nothing wrong with this, right? But just while we do this, we can make it a little bit smarter. We can say while Q. What we need is a temporary, but we know the temporary, we can get it. So like the temp equal to for child in node dot left, node dot right. See, they got some issues. If child, and then we put, has to be for each one inside the queue, right? It should be for node in queue, node in queue, and then for child in this and this. If child, then we put child here. So this shall be the new queue. Queue shall be this, right? But then, yeah, that's, we get each new queue, right? We get a new queue. We get a not new queue. We get a new level. This queue is a level, and then by the end, queue will be empty. So all we need to do is just store the pre. So I have a pre and a queue, and we're gonna change all the queues just to queue. It's just too long. It's way too long. This queue, and this is also, let's just call it n to shorten it. And child, let's just do C. For child in node, the node in queue, all right? I don't like it. I don't know, the child is coming out, so I kind of know what we're doing. So like that, and at the end we just need to sum, return sum, all right? N.val for n in pre. All right, I think that is the, try it. Error. Is not iterable. I didn't iterate it. Oh, pre has to equal to q. Yeah. Yep, and this is correct. So the pre has to equal to q. Forgot it here. Pre has to equal to q, and yep, call it. This is the smart BFS by Lee 215. I want to link it as well. It's pretty smart, huh? Sometimes you have to admire, like, these people are just really smart in doing this type of thing. And I want to write some more. It's the same BFS, but implemented implemented as a level traversal. We end up with the nodes in the last level, but we do not do any computation while at each level. Yeah, and also it has good use of this comprehension. That's a good solution, very good solution. All right, I'm curious of other people's solutions. Recursion, of course you can do a recursion, but why would you do recursion? Right? Why would you want to do recursion? You have to pass in level, and if level larger than max level, sum because of 0, okay. If max equal to max level, then we do, how do you know the max level then? Oh, you're updating here. So every time you go to the new level, and my current level larger than, I just get the sum to 0. Don't do anything. And not like don't do anything. We reset, and then we add its value. and then we go to the next one, and then eventually the max level will be set. Like as we go down the left, right? We'll go down left all the way to the end. We will have the max level set at the end, and then as we bubble up, right? As we bubble up, the sum is here. Yes, max level is here. As we bubble up, and then every time when they hit the max level, we'll add. Yep, that's a good one too. Simple recursion, DFS, BFS, to DFS, DFS1, DFS2. Oh, why you have two DFS? I don't want to use this to. Yeah, it's polluting my eyes. I like this one. I like this one. Yeah, I like this one. To constantly updating on the max level, and definitely level traversal or my own. It's BFS is definitely a better solution. All right, that'll be it. That'll be it for today. Pretty fast, pretty straightforward. Guess we got lucky again. All right, we got lucky again. It's been like what, one balanced streak of a whole week. I think it's a whole week that we haven't encountered anything like serious. So let's hope this streak can continues. And that will be it. See you guys tomorrow. Adios.